Hey everyone, how are you? I hope you all had good food. I know it's the session after food, so usually you are digesting, so I'm gonna try to wake you up. So thanks for coming here. I'm with Jamie from Dagster. You want to say hi? I'm Pierre. I'm the CEO at Notable. What I'm gonna show you today is the work of the engineering team at Notable, and so Matthew Seal, who is maintaining the Peppermill repo that maybe you might be aware of if you work with Jupyter Notebooks and orchestrate Jupyter Notebooks. So we're going to showcase the work we have done and what we have done in the open source repo as well, which will help you to replicate that workflow for 95% of what we're going to showcase. And 5% is just using our UI to render the notebook. So we're going to see new tutorials. But the part of the workflow and the use of the SDK is completely open source, and Jamie is going to run you through how to set that up as well and understand each step of what happens. So we're gonna just have 2 or 3 slides to set the context, but really jump into the workshop as fast as we can, and have a long session of Q&A after if you have questions. I think that's the best setup. I mean, I'm only gonna spend 10 seconds on that slide, but the main use case and pain point we're trying to tackle is when you create or maintain data pipelines, you have a lot of errors for many reasons. It can be a data drift, it can be just typo, it can be someone who changed an input or dependency. You have errors basically as you're trying to debug. And it can be very cumbersome to debug those errors and to lose time to have to rerun your entire workflow. For example, if you miss a deadline to produce a report or a dashboard, or someone is now stuck because they don't have the dependency that they need for their own kind of maybe ad hoc analysis or their own workflow that relies on yours. So what we focused on is really trying to think about, that's a classic experience that Matt usually gives a talk about when he demonstrates at Netflix. They're very difficult workflows to maintain and very cumbersome. For example, you want to produce data that can be surfaced in a solution such as Tableau. You have so many technologies that are involved and so many people who have to maintain this different part of the workflow. So it's very difficult for people to collaborate or even debug an issue, and that's why we really focused on that pain point. What we're going to use today, we're going to use Gitpod. It's optional. You can use it or you don't have to use it, but it's an easy way for Jamie to showcase how to do the setup. We're going to use Dagster, we're going to use Peppermill Origami, and Origami. And Peppermill Origami and Origami are the work we mainly did to enable the workshop today in collaboration with Jamie here from Dagster. So I'm not going to go into more details about those, but after the workshop, when we have the Q&A session, we can talk about those efforts specifically and why we made some decisions. So, I mean, I went over that. The goal is to shorten the feedback loop to basically enable live troubleshooting of notebooks that are used as assets as part of the DAG. This is an overview of overall information architecture of Notable and Dagster and how they communicate with each other. Again, just to show you the slide, we can go back to it in the Q&A. But for instance, to give you the overview before we dive deep into it, we're going to rely on an API key. Notable tracks version of a notebook that is associated with a version set of dependency, which we're going to be here, the hardware, the image, and the project files. There is a notification system, and we use Peppermill to have the 2 tools interact with one another through the materialization of that asset and through the parameters, of course. So I'm going to hand over to Jamie to talk about the Dagster side, and then we're going to jump in on the workshop.
So, hi everyone. My name's Jamie. I am a software engineer at Elemental. And Elemental is just the company developing Dagster, which is an open source product. We'll go through it today, along with the integration with the Jupyter notebooks and Notable. Cool. So I'm going to be running the workshop, and in the workshop, we're going to basically just be taking a Jupyter notebook and productionizing it as part of a data pipeline. That Jupyter notebook is just going to do some classic analysis of the iris data set. So before we get into that, we'll spend like 10 minutes doing like a little like design process. We'll kind of go through what a data pipeline is, and we'll go through designing the data pipeline that we're going to implement. And that'll provide kind of like a nice framework for learning about two different paradigms of data pipelines, the task-focused data pipeline and the asset-focused data pipeline. And then we'll just kind of go into like, what is Dagster, how does that fit into everything, and we'll learn all of the Dagster APIs and concepts that we'll be needing. So we can just start off by defining like what a data pipeline is in broad terms. So a data pipeline is just a series of computations that result in some deliverables or data assets. And a data asset can be a lot of things. It could be like a table in a database, an ML model, some kind of like report you distribute to people. And today, one of the ones we're going to be working with is a Jupyter Notebook. So a really classic example of a data pipeline is the ETL pipeline. So for anyone who's kind of not super aware of what an ETL pipeline is, basically the first step, we fetch data from some external data source. And then we might do some transformations to that data, we might clean it up, join some data sets together, whatever we need to do to get our data into a usable form. And then we just store that data in a data warehouse where we can use it later. So let's start applying what we're going to do today to this ETL pipeline. So the first thing we'll need to do is actually like fetch our iris data set. And for something like this, we could either write custom API calls ourselves, or we could use a tool like Airbyte, which does data ingestion without you having to write those API calls. And for the sake of making this kind of like data pipeline exploration and design phase a little more like the real world, let's assume that instead of having like a nice canonical iris data set, that instead there's like a group of scientists somewhere. They're constantly publishing new data about different flower species, and we want to fetch data from that database so that we're always kind of using like more up-to-date data. So once we fetch our data, we will transform that data set into the data we want to analyze, and for that we could use a specific data transformation tool like DBT. And the last step stays pretty much the same. We just store our data wherever we want it to go. And in this case, let's just say we're storing it in Snowflake. So the last thing we need to do here is add our Jupyter Notebook into this pipeline. So we'll add a step at the very end that fetches the data from Snowflake and executes it in a Jupyter Notebook. So I just want to take a little sidebar and just say that I've kind of named a couple of different external tools as part of this data pipeline explanation. And if you aren't like familiar with all of them or any of them, that's totally fine. We're not going to be using them as part of the workshop. I just am kind of mentioning them so that if you are familiar with them, you kind of can route this data pipeline that we're designing into some that you've maybe seen or worked with before. Okay. So now we have designed this data pipeline. We know exactly what tasks we need to execute, and we know where our source data is coming from and where our data ends up. So we'll call this the task-focused data pipeline, because sort of the main object that we're modeling is the tasks that we're executing. All right, so let's think about what might happen after we've gotten this pipeline up and running. Let's say it's running really well, and soon we get a request to analyze daffodils too. So we'll add more code to the step that fetches the data, more code to the step that does the data transformations, and we'll end up with some daffodil data in our Snowflake database. And then maybe after that, we get a request to analyze roses too. So we'll go through that same process and add the rose data. So here you can notice that even though we've created some new tables and our data pipeline is responsible for handling more data, we don't really have a good way of documenting that in the individual tasks. Nothing has happened to the way we're sort of modeling this airbyte task in our data pipeline that tells us that now it's fetching like 3 different data sets. So our tasks are responsible for handling more data, and this also means that like bugs are going to become harder to track down. So if our DBT transformations fail, we're not really sure if it's because there's a problem with the DBT models or if there's something wrong with the actual like source data sets. So how can we fix this problem? If we start looking a little closer at our data pipeline, we'll start to see that it's made of more than just tasks. So each of these tasks actually produces data assets. So our task to fetch the raw data from the flowers database produces tables for each species. And the data we're storing in Snowflake is exactly the same data that comes out of the DBT task. And finally, our Jupyter Notebook creates this executed notebook file, and that's actually what we're going to be like sharing around to share our analysis. So the data sets and the Jupyter Notebook in these green boxes are what we actually kind of care about in this data pipeline and the actual like data objects that we'll be working with if we want to like do more data analysis or like kind of understand like the artifacts that our data pipeline is producing. So let's try reconstructing this exact same data pipeline, but like focusing on those data assets rather than the tasks. So the kind of like first thing to do, just kind of ground us in this exercise, is we should kind of go through our legend and determine what objects we're actually going to be modeling. So we'll need a way to represent our external data source, which in this case would be our like flowers database. And then we'll need a way to represent each of the data assets that gets created throughout the data pipeline. We'll be connecting those assets with edges that represent data dependencies. So at the end of an edge, the asset at the end of an edge depends on the data at the beginning of the edge. And then we'll still want to kind of document how those assets are created. So we'll, like, along the edge between assets, we will document the tool or like process that created that asset. Okay, so let's break out just the iris analysis part of this data pipeline first and go through the process of making that. So we can start by fetching the iris data from the flower database. Again, we've documented that we're using that with airbyte here. And then we can transform that iris data set. And that becomes kind of like our final iris data. And that data gets fed into our notebook and executed. So when we want to add additional assets to this pipeline, like our daffodil and our rose data, pretty simple. We can do a really similar process and make the data assets for the daffodil data and the rose data, and just kind of document how those are flowing through our data pipeline. So we end up with a data pipeline that maybe looks a little bit larger, but it's doing the exact same thing as the pipeline we've modeled before. But this one's a lot more descriptive about the data it's processing and where that data is and like maybe what type of data we have. And we kind of have a much better idea of how our data relates to each other in this pipeline. So let's just do a quick like visual comparison between these two pipelines. There's quite a bit going on this slide. Don't feel like you need to parse all of it. The main point is to just demonstrate that when we model our data pipeline based on tasks, we end up with something that looks very different from when we model our pipeline based on the data assets that we should produce. So there are some situations where like this task-based approach kind of makes more sense or is like the correct design decision. But at Dagster, we think the majority of data pipelines should really be asset-focused. Again, we sort of think about it like the point of your data pipeline is to produce this data and understand what data you have available. And so it makes sense that those data assets are like the primary thing you look at when you design your data pipeline. Kind of some more motivation for that. If you have your task-based pipeline, there's sort of this like increase in cognitive burden in what you have to understand about the pipeline in order to know what data you have available. Because like what data you have, you actually have to like dive into the definition of each of the tasks and see what it's doing. So when you want to add some new data, you have to like go back into your pipeline, potentially relearn what it's doing if you've forgotten since the last time you did some work, before you can actually start doing your job. And so there's like some time loss there, and just general like inability to like easily parse and understand what's going on in your data pipeline. Okay, so how does Dagster fit into all of this? So Dagster provides a framework for building and executing these asset-focused data pipelines. Dagster additionally does support task-based data pipelines or like other workflows, since there are like cases where those are needed. But like I mentioned before, we sort of think asset-focused data pipelines are or should be what's used in the majority of circumstances. So we're going to be focusing primarily on that feature set today. So using the Dagster APIs, you can create this graph of assets that span across a bunch of different technologies that you may be using in your data stack. And you can link these tools together into this like nice cohesive workflow. And additionally, Dagster will kind of reveal the assets that are already a part of the data tools that you're using. So for example, when you load a DBT project up into Dagster, rather than just seeing like a single DBT run task, each model will become its own asset in the graph, and you can kind of see the dependencies between models. So in the workshop today, like I said, we're going to be taking a Jupyter notebook and making it part of a Dagster data pipeline. So let's go over kind of like the main Dagster concept that we'll be working with. So the most important thing is the software-defined asset. And in Dagster, we define a software-defined asset as like software declaration of a data asset you expect to exist. So just to remind everyone, a data asset can be a lot of things. Tables and databases, ML models, files somewhere in storage, or like a Jupyter notebook. And when you go to write a software-defined asset in Dagster, you need a combination of like 3 different things. So the first thing you'll need is the name of the asset. So here we have the name of our asset is like iris data. You use this little asset decorator in Dagster to like tell Dagster that you're writing an asset. And then you will also specify the names of any upstream assets that it depends on. So in this case, we've created a dependency between a raw iris data asset and then passing it as a dependency to our iris data asset. Kind of behind the scenes, Dagster can do this name matching between the asset name and the parameters that other assets expect to get. And finally, you need the Python function for updating or creating the asset. So here we've got some pandas work to fetch our data set in, and then we're changing the name of the columns. And those are being stored as 2 separate assets. So once you've written these assets, you can view the resulting graph in Dagit, which is Dagster's UI. We'll be kind of going into Dagit like as part of the workshop, so I won't dive into it too much here. But from Dagit, you can materialize the assets. And when we say materialize, basically what we're saying is we're executing the Python function from our assets and storing the resulting data in a persistent location. So kind of a useful exercise will be to kind of walk through what happens when we materialize these 2 assets. So the first thing Dagster is going to do is see that our raw iris data doesn't have any upstream dependencies. It doesn't need any parameters. So we'll execute that first. So I'm going to run this pandas call, return the value, and then save that value in a persistent location. By default, that's to like your local file system, but you can set it up to be like ECS or, sorry, not ECS, S3 or GCS, or Snowflake, or all kinds of other locations. Okay, so then Dagster is going to see that the raw iris data asset has been materialized, which means that the iris data's upstream dependencies have been like fulfilled, and it can run now. So again, this is kind of where some like Dagster magic happens. We see that the parameter for the iris data asset matches the name of the other asset that we've defined. And And so it will load the data from the persistent location that we stored the iris data in, and then execute this Python function. And then it will additionally store that data into a persistent location as well. Okay. So like storing in a persistent location is actually like kind of quite important here. And that's because if we decide we want to materialize these two assets again, Dagster is going to like overwrite the data in this persistent location. So it's storing in the same location every single time. There's some kind of nice benefits to this. One is that if we want to like manually go in and inspect the data, we know the exact location to look at. So there's no more like going into some bucket of files and trying to parse like which one has the most recent data. And then another benefit of this is that we can also tell Dagster to just materialize one asset. So if we only wanted to rematerialize the iris data asset, what Dagster is going to do is fetch the data that we previously stored for the raw iris data asset, and then use that data in our function, and then store the output again. Okay, so Dagster also has like built-in support for working with notebooks, and we do this with a library called Dagster.mill. Dagster.mill is just like a thin wrapper around a paper mill. And this allows us to execute Jupyter notebooks as part of your data pipelines. So instead of like maybe doing a bunch of development work in your Jupyter notebook and then having to like copy paste that into Python functions, you can just run the Jupyter notebook as part of your data pipeline. And then you can also just like connect your Jupyter notebook to assets that are already in your pipeline, so you don't have to like rewrite like the fetching or like data loading logic. There are also some like additional kind of nice features. We'll see them when we get into the workshop, or like additional metadata and like lineage tracking, and you can view your notebooks directly in Dagit without needing to start a kernel. Okay, so we're going to get into the workshop portion. I need just 1 minute to open up a new file, and then we can get started. So if you want to pull your laptop out, and then we can get going. Okay, good? All right, so like I mentioned, we're going to be going through this process of productionizing a Jupyter notebook as part of our data pipeline. And more specifically, we're going to be doing like a simplified version of the data pipeline we just designed. So we'll only be creating 2 assets, one for our Jupyter notebook and one for the iris dataset. Since we're working directly with like the canonical iris data, we just need to fetch that data. We don't need to do any like cleaning or transforming of it. So that kind of skips that middle step. So our Jupyter notebook will take the iris dataset as input and then do our analysis. So for each step in the workshop, basically I'll talk through what we're going to do. I'll demo it up here on my computer, and then I'll go back to a slide that has like all of the steps you'll need to complete, and we can wait like 3 to 5 minutes, kind of depending on I don't know how much we're doing as that step, and get everyone up to speed. If you run into any issues, just feel free to call me over here, or Dave is right there, and we can try and get you all sorted out. During the first step that we'll get to in just a second, we'll be like downloading some code, and with that you'll also have a README that has all of the steps you'll need to complete. And you'll also get like a completed version of the workshop. So if you're the kind of person who just wants to like listen, still wants to see the final version of the code and maybe play around with it a little bit, you'll be able to do that too. All right, so we should get ourselves set up with virtual environments so we don't have any like dependency conflicts or run into like, I don't know, annoying like Python package issues. So to do that, I'll be using a tool called Gitpod. This sort of just like creates a fresh Python environment for you that you can work with in your browser. If you're up to trying that out, I would highly recommend it since it'll kind of get us all working on like the same base. It'll be kind of easier to I don't know, debug any issues since we have sort of like common ground. But if you're more comfortable working with like another virtual environment tool, like also just feel free to use that. The only requirement is that you use a Python version greater than 3.6. So if you do use Gitpod, eventually you'll kind of get dropped into what looks like a VS Code editor. And once you get there, we're all set to go. You can hang out here and until we get their environments all set up. Okay, just doing a quick check-in. Does anyone want some more time before we move on? Okay, cool. All right, so the next thing we're going to do is get our workshop code downloaded and get all of the dependencies we need installed. So if you're in Gitpod, there's a terminal that opens up here. Otherwise, you can use your terminal on your computer. And I'm going to just type the commands to get all the dependencies installed up here so you can see them while I go through them here, and then I'll go back to that slide that I'll have them as well. So I'm just gonna upgrade pip just so that everything is like consistent for everyone. And then we need to install Dagster. Dagster comes with this project CLI that lets us kind of like install like like official or like well-maintained example projects. So we'll be installing the one called tutorial notebook assets, and then we're just going to give it a name with this name command, and that's the name of the folder that will be created on your computer. And then the last couple of commands are just like going in there and then installing the dependencies of the project. Oh yeah. There we go. Yeah, absolutely. All right. Does anyone want a little more time to get through those commands, or get to move on? Okay, let's move on. All right. So let's do just like a little tour of everything that we've downloaded here. So in our Dagster notable demo folder, we have these kind of two subfolders. We have a tutorial finished folder and a tutorial template folder. The finished folder is where you'll find like the completed version of this project. So if you want to get like a preview into what we'll be doing or just kind of see the final version of code, that's where you'll go. We have the README here that has all of the steps if you want to just like follow along with them there. All right, and then in the tutorial template folder, we've got some subfolders. The first one of note is this notebooks folder. In here, we've got the Jupyter notebook that we'll be working with. I recommend just like opening this folder and getting it kind of like saved to your workspace, or like the tabs up here on the top, so that way you have easy access. You should see this comment at the top that will be like filling it out as part of the workshop. If you don't see that, you might be in the finished version of the workshop. And then the other file we'll need is in the assets folder. There's an init.py file in here. Again, we have this comment up here at the top, so you know you're in the right spot. You should see a bunch of commented out code. And that's because we're not going to be doing like a bunch of like coding from scratch. It involves like a lot of me like presenting code up here and then you having to type it out perfectly locally. So instead, we're just going to be like uncommenting code snippets, and I'll be walking through what they all do. So you'll still get like a good understanding of what's going on. Yeah, so you can get both of those files opened up, and then we can move on a bit. I imagine opening those won't take very long, so I'm just going to hop on to the next thing, which is basically I'm just going to like walk through what this Jupyter notebook is doing. Because additionally, we're not going to be doing a ton of work in here either. So, kind of like I mentioned before, we're just doing some like analysis of the classic iris dataset. If you're familiar with the iris dataset, you may already be familiar with the type of analysis we're doing in here. But basically, we fetch the dataset, we start kind of exploring that dataset, maybe doing some like descriptive analysis, some plotting. So, at the beginning, we're just kind of like looking at what the dataset looks like, and then here we'll start making some plots. I'm actually going to start executing all of these cells so you can see the output of them. But you don't need to execute this notebook locally unless you're kind of interested in seeing it. So yeah, we're going to kind of start looking at what the notebook's up to, or what the dataset looks like, and then we start making these plots where we're comparing like different dimensions of the dataset that might be what's going on. Box plots do the same thing. Because I'm so zoomed in, it's hard to see these all together. And then we get into our actual like k-means analysis, where we're going to try and like distinguish the different species of iris from each other. So we do our analysis, and then we're going to do some plotting to look at our results. And then we end up with this plot at the very end, which kind of shows us how our iris species are getting like clustered. Okay, so that's our notebook. Let's get into writing some actual code. So we're going to go back to this init file that was in the assets folder. Again, you should see this little comment at the top, so you're in the right place. And the first thing we're going to do is scroll down a bit to where there is a to-do one comment. And all we're going to do is uncomment this code block that's underneath it. And this last line should stay commented. We'll get to that in a little bit. So you should end up with a code block that looks like that. So what's going on here is that we're trying to make an asset from our Jupyter notebook that we were just like looking at. And this, maybe looks a little different from the sort of way of defining assets that we went over in the presentation. So if we were to define it more like that, you might expect to see a block of code like this, where we define the name of the asset, we give it that asset decorator, and then we execute a bunch of code in the function, and we return our executed notebook. And the problem with this is that actually executing the notebook is quite complicated. There's a lot of work to be done, and so we created this helper function, define Dagster asset, to do it all for you. So what this function is doing is it's taking the notebook you want to execute, the name you want to give your asset, and a couple other parameters I'll talk about in a second, and it creates this asset and returns it. So we don't need this that I copied up here, just this define Dagster asset function. So yeah, the one parameter so far that I haven't talked about is this group name. And this is just sort of like an organizational feature. When we get into Daggett, I'll show it a little more, but it just lets you group different assets together and say like these assets are related to each other, and this other set of assets are related to each other. So we'll just hang out here for a minute, and then we'll move on. Okay, how's everyone doing? Good to move on? Does anyone want a little more time? Okay, great. All right, so let's get into actually like executing. Sorry, my computer froze. Okay, I can actually get into executing these assets or materializing them. So to do that, we need to launch Dagit, which is Dagster's UI. So to do that, in your terminal, you can just type the command Dagit, D-A-G-I-T, and then hit enter. If you're using Gitpod, it's going to pop up this little dialog about opening port 3000, and then there will be an open browser button. You can click that. If you're working more locally, it prints out this log statement saying that it's serving Dagit at port 3000, and you can just navigate there in your browser to open Dagit. Okay, so this is kind of like your landing page for Dagit. This is kind of what we call the timeline view. It will show you sort of like the historical runs of any like assets you've materialized or any like task-based work you've done, and show you whether it's like succeeded or failed. Since we haven't run anything yet, this is totally empty. So if we go up here to this kind of left hamburger menu button in the top left, and open that up, we get a kind of our left side panel. And here we see kind of like our two sort of Dagster repositories we have going on. A Dagster repository is just like your collection of like assets and other Dagster objects. We have one for the finished version of the tutorial and one for the template version. So again, if you're interested in just kind of like seeing what we're getting to moving forward, you can poke around in the finished tutorial. But to see the code we've actually been working on, you can click this little arrow in the template tutorial and open it up. There's this ping notable job in here. This is, you can kind of ignore it for now. It is for later, just to help in case we have any like connectivity issues with like setting API tokens for getting into Notable. So you can ignore this for now. And then we can see under the asset groups, kind of like menu subdivision, we have our template tutorial group. So you can click on that. The template tutorial group name comes from this group name we set in our asset. If we click on that, we get to this sort of asset graph view. And we can see all of the assets that are part of that group. Right now, we just have the one. We have the notebook. So from here, you can click on this asset, and we get this little right side menu. After we've materialized it, this will be populated with some more metadata that we might find interesting. But for now, we get a little description of what's going on, where the notebook is located, and we can view our source notebook directly in Dagit. Okay. So to actually go ahead and materialize or execute this notebook, we'll go up here to the materialize button, and we just click on it. And then this little alert will pop up with a view button. If this alert goes away before you have the chance to click on it, you can also click on this little hash that appears at the bottom of the asset. So yeah, I missed it, so I'm going to go and click here. And this will open up a new tab that contains all of the logs from executing your notebook. So we can sit here and we can kind of like watch everything come in, and we can see that our notebook executes successfully. Once we've done that, we can just exit out of this tab. And in the right side panel for the asset, we get some new metadata entries. And we actually get a metadata entry for our executed notebook. You can click that button and see the notebook that was actually executed. And the reason we can do that is because, like, behind the scenes, when Dagster is executing your notebook, it isn't like overwriting the source notebook that we wrote. It's like executing that notebook with papermill and then writing that executed notebook to a new location. So you can use the executed version of your notebook and then still go look at the source version of your notebook. So I'll give you a minute to just go through like materializing your notebook for the first time, and then we'll move on. Okay, does anyone need more time? Okay, let's move on then. So let's take a look at our notebook again. So we have our notebook executing as an asset in Dagster, but we're still fetching our iris data set as like the first thing we do in our notebook. And we want to kind of pull this data fetching step out of the notebook and make it its own Dagster asset. And we want to do that for a couple of reasons. The first one is that by kind of like refactoring the iris dataset out of the notebook, it'll let us reuse it in like future analysis. So if later we come in and we want to do, make a second notebook that does other analysis, we can just reuse that same iris asset, and we don't have to like rewrite our data fetching logic. And the second reason is that it'll allow us to use some of Dagster's like built-in functionality around like rematerializing assets. So once we've materialized the iris dataset once, we can just repeatedly materialize our Jupyter notebook asset, and it'll like keep fetching the data that we already fetched for the iris dataset. So that can help you like reduce like I/O costs if you're like making expensive API calls or things like that. So let's go through the process of making an asset for our iris dataset and getting it set up as like an upstream dependency for our notebook. So to do that, we're back in the init file in the assets folder, and we're going to scroll up to the top where there's this to-do-to label. And we're just going to uncomment this code block here. And what's going on here looks a lot more like the asset declaration that we went over in the presentation. We've got our asset decorator, the name of the asset, and the function for creating it. Again, we're putting this little group name here just for organization, and saying that like this iris dataset asset belongs to the same group as the notebook asset. All right, and then the next thing we need to do is actually tell Dagster to use the iris dataset asset as input to our Jupyter notebook. And so if you scroll down, that's where this ins parameter comes in. So we'll uncomment this line. And what's happening here is basically when Dagster goes to materialize all of these things, it sees this ins dictionary, and it's going to say, oh, I need to provide an input variable named iris, and the value of that variable needs to be the value of the iris dataset asset. So it's going to then fetch the data we stored for the iris dataset asset and provide it as an iris variable in to the notebook. And we'll get through the actual step of the final step of getting it into the notebook. All right, we good to move on? Cool. Okay. So the last thing we need to do before we can get back to materializing this is update our Jupyter notebook to accept an injected parameter from Dagster. So again, behind the scenes, Dagster is using Papermill, and Papermill allows you to inject external values into your Jupyter notebook. And the way Papermill does that is by looking for a cell with the tag parameters on it. It deletes that cell and then replaces it with a cell that injects the parameter. And so what we want to do is we want to, instead of fetching the iris data set in our notebook, we want Papermill to delete that cell and inject a new cell that will load the value of our iris data set asset that we already materialized. So typically what you would do is you would go into your Jupyter Notebook editor and you would just add a parameters tag to this cell. But the Gitpod editor doesn't let you add cell tags. So we have a tag or a cell here that we've already tagged with parameters. And so we're just going to cut the code from this cell and put it in this cell. A little bit of a different workflow here, but it's not too bad. And then you can just go ahead and delete this empty cell. We don't need it anymore. Okay, how's it going? Good to move on? So in the notebook, it just has this comment saying that it's been tagged with parameters. you won't actually see the parameters tag. This screenshot is taken from like a local VS Code editor, and you can see the parameters tag down here. But when you're in Gitpod, you don't get to see the actual tag. It's there, I promise it's there, but we just have to put this comment here instead. I can come take a look if you're having a hard time finding it. That's helpful. Okay. Yeah. All right. Yeah. As long as your code is in the cell with the comment saying it's been tagged with parameters, you should be good to go. Okay. Let's move on to materializing all of this. So we can go back to Dagit, and we'll need to click this Reload Definitions button up here. And this basically tells Dagster to go look at your code again and pull in any new assets that we've defined. So we will reload definitions, and then we should see our iris dataset asset pop up, which we have. And again, we have this dependency of that our Jupyter notebook needs the output of the iris dataset in order to run, and that's because we set that in dictionary. So again, when we execute this, first Dagster is going to materialize the iris dataset, and it's going to use Papermill to delete that parameter cell in the Jupyter notebook and insert a new cell that will load the value of the iris dataset asset. So we can go ahead and we can click Materialize All. That'll materialize both of the assets here. And we'll click View, and then we'll watch this go through. All right, here we go. So our notebook has executed successfully. If we go back here and we click on the executed notebook button, we can actually see the cell that Dagster injected. You don't need to understand what's going on here. It's like some, I don't know, Dagster internal implementation stuff. Basically, we're loading a parameter iris, and Dagster knows that that means it's the iris dataset asset that we defined. Again, we can kind of just quickly scroll through. I'll give you a minute to go through all that. If you run into any issues, like definitely let me know and I will come take a look. All right, is everyone good? Cool. All right, so let's just quickly take a look at what we've done here. We've basically designed our data pipeline. We have our iris dataset asset, and we're using that as input into our Jupyter notebook, and we're materializing both of those and getting our executed notebook asset that we could then share around to anyone who's interested. So we're going to shift gear a little bit and start talking about Notable and using a Notable notebook in this pipeline. So the first thing we'll need to do for that is make a Notable account if you're interested. Notable account is free, and we can kind of go through the rest of this workshop together, or you can just watch along and see how it works. Yeah, how's that going? I know like signing up for stuff can sometimes take a little minute with like email verification, but if we're good to move on, we can do that. Okay, there's like a little bit more setup we need to do before we can materialize things. Like the first one is we actually need to get our notebook up into Noteable. So if you're working locally, you already have your notebook on your computer, but if you're in GitPod, we'll need to actually like download the notebook. So to do that, we can just find our notebook in the left sidebar, and if we right-click on it, we'll get this download button. And we'll do that, and it'll download, and then we'll have it for uploading to Noteable. And to do that, when you open up Noteable, you should have this sort of like space that you land in. If you aren't there, you can click the Noteable icon in the top left, and it'll bring you back to that space. Kind of the default project that should be made for you is called My First Project, so we can just click into that, and then click the upload button and upload our notebook. And then once we've done that, we can open this in a new tab so we have like easy access. All right, is everyone done uploading their notebook? Good to move on? Cool. All right, so last bit of setup we need to do, we need to get an API token from Noteable so that our Dagster code can talk to Noteable. So to do that, in your main Noteable page, you can click on your profile in the top right, and then go to Settings. And then in the left menu, there's an API tokens page, and then you can create a new key and then just copy that value. And then we'll go back to GitPod or whatever terminal you're using to run Dagit. And here we want to Control-C and kill the Dagit process. And then we're going to create an environment variable for our Noteable token. So export the name of the environment variable should be Noteable_token. Do an equal sign, and then copy in the value of the API token that you copied from Noteable. I've already set mine up before this. And then once you've done that, you can just open up Dagit again. move on to the next step. So now we can actually go into, oh, you need another minute? We're having an issue. Okay, cool. Good to move on? Okay, so yeah, so we need to get a Dagster asset set up that will actually like execute this notable notebook. So we'll go back to Gitpod, we'll go back to our init file where we've defined all of our other assets, and then down at the bottom, we've got some more code for you to uncomment. And this time, we're using the Papermill origami library with the Dagster integration to define a notable like Dagster asset. So this looks really similar to the Dagster asset we defined before. We just give it the name we want the asset to have. We're setting up our inputs. We have the group name. The only thing that's different is this notebook ID. And to get the notebook ID, we'll get that from the notable notebook we uploaded in just a second. Get that done. We're coming up a little close to time. If we're good to move on from this, we can do that. Yeah, we're going to do that after this, yeah. Cool. Yeah, unless anyone's still working on this, we can move on to the notebook ID stuff. Great. So to get the notebook ID, we just want to go back to the notebook that we uploaded to Notable. And then up here in the URL bar, there's like this string of numbers and letters, and we're just going to copy that and set that as our notebook ID. Cool. Good to move on to next. Okay. All right. So now we're back to being able to materialize everything in Dagit. So we can go back to Dagit. Again, we want to hit the reload definitions button so we can reload all of our assets. And we'll see our notable asset pop up down here. So we want to materialize the iris dataset asset and the K-means notable notebook asset. So to do that, we can hold down the shift key and then click on both of them. And then the materialize selected button will just materialize the two things that we selected. our view button, and we can watch everything happen. So once our notebook starts executing, we'll actually get a link to a Notable notebook to watch the execution happen. So kind of behind the scenes, Notable, similar to when we were working with Dagster, is like making a copy of your source notebook and then executing that. So you retain like a version of the source notebook that you can go in and edit and change, and then you still have the like historical executed copy. Yeah, so there's like a view button alert that pops up. If you don't see that, you can click on this little like hash down here in the bottom corner, and then that should open up a new tab that has this flow. Great. So then in the logs, you'll see this entry that has like a parameterized notebook URL and a link. And we can click that, and then we can like watch our notebook as it executes. Here we are. And then once your notebook's executed all the way through, you have this sort of like artifact or like link that you can share out to people. So let's hang out here for a minute and then move on to like the very last thing we'll do, which will be like some live debugging. And hopefully that'll happen pretty quick and we have some time for questions at the very end. So we're good to move on to actually like debug a notebook error. We have to like introduce an error. So we'll do something really simple. So we'll go back to our notebook. We want to do the like original like source notebook, not the notebook we just executed. But here in our original source notebook, we can scroll down a couple cells. I'm going to insert a cell right after this iris describe cell. And we'll just raise an exception. And I just want to like make sure this notebook's saved, so we can just like wait a couple seconds just to make sure it's working. And then we can go back to Daggett and we'll materialize everything. So just hang out here for a second for everyone to get that done, and then we'll go on to the materialization portion. All right. So what we'll do is kind of similar to what we've been doing before. We'll go back to Daggett, we'll materialize the asset, and this time we can kind of just like wait for our notebook to fail, because we know it's going to fail because we wrote that exception in there. So we'll wait for that to fail, and then we'll kind of like investigate like what that debugging flow looks like. So maybe a more like real world example of this is like you might have this notebook executing on a schedule. Dagster has some like built-in like schedule functionality, so maybe you have this set up to run every hour, or once a day, or whatever. And you get an alert that your notebook failed, and you want to go in and you want to see what's wrong. So we're going to wait for our notebook to fail, and then we can click on the link to our notebook. That's going to open up like a live version of that notebook. So all of the cells up to where the error happened are still executed, like those values are still live, and we can kind of investigate and explore them. And then we'll be able to figure out what the error is, fix it, and we can execute the notebook to completion. We'll just wait here. If there's notebook fail, it has to go through the first couple of steps, and then we'll get into that process. There we go. Okay, so we get our stack trace and Daggett, get some general idea of what's going on, but we can scroll up and we can click the link into our Notable notebook, and we can see kind of like all of the executed cells up until this point. And we can still look at this data if we want to investigate the iris data set again, like it's already loaded into the kernel, like it's good to go. And then we can just fix our issue and execute the rest of the notebook. Yeah, and that's like basically all we're doing in the workshop. That's it. So we can, in the last like couple of minutes we have left, we can open up for any like questions you guys have. And since we don't have that much time, if you have any like follow-up questions that you don't get a chance to ask, feel free to like, email me, or you can email Dave, or if you want to join the Dagster Slack channel, you can ask questions there as well. Our engineers are really good about monitoring it, and we answer questions pretty quickly. Okay. Mm-hmm. I mean, that's like a much larger discussion. I would highly recommend like maybe going through like our doc site and looking at some of the content we have on some of those like features of Dagster. I would say like the main distinguishing feature is like this asset focused approach to data pipelines, and we really think that like helps like streamline your workflows or like give you a lot like better insight into like the data you're actually working with. But yeah, again, I would say that's like we have a lot of content on our docs and like our blog, kind of addressing like the ways we think like Dagster approaches this sort of like larger data orchestration space. So I would recommend like looking at those. No, you definitely could do your like a lot of like your initial like development and iteration in the notebook. Like the whole point is that like you could do a lot of your development in the notebook and then easily slot that into like a Dagster pipeline. You might do that like little refactor step of pulling some of the data fetching out so that you can reuse it in other spots. But like the process of like developing in a notebook can be like really good. The idea is like you can just like kind of like pick up and drop it in, and then it just works.
Yeah, and I think what's key as well is that you also demonstrate how you move away from creating only if there is one specific part of your workflow that is appropriate to that, you can slot that in directly so you don't have to like keep that one definition of what should be production and take the best basically.
Yeah. No, so I'll just take a step back. So Dagster, we have like our open source product. We also have like a paid cloud product, but scheduling is available everywhere. I won't like get into the actual like code right now, but basically there's just like another decorator you can apply to like a Python function. So you can say like do like at schedule, you give it some values of like how often you want it to run, and then you just basically like tell it what assets you want to materialize or like what other like tasks you want to kick off. And then that becomes part of your like Dagster like project or repository, this like collection of objects. And then in the Dagit UI, there's like a tab for schedules, and you can see all the schedules right here. We're not really set up to run schedules right now, but yeah. I actually don't know. Yeah, I'm not sure.
Which one?
The octopus? Yeah, no, there's a lot of debate over actually what it actually is, if it's like an octopus or a squid or like a cuttlefish. Yeah, I don't actually know what the story behind it is. All right. Yeah, thank you all so much for coming.
Yeah, thank you, everyone.